Hello and welcome back. This is part 2 of Class A Subnetting, which is a continuation of our network series. In this example, I was showing you how to do Class A with /9. But in another example, I want to give you a bit longer subnet mask. So let's say we have an example of 10.0.0.0/, in this case, maybe 26. What does that mean? You would say the IP address subnet mask usually for class A, it will be N, and then it will be host, 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 which means we have 8 bits of ones here, 1, 2, 3, 4, 5, 6, 7, 8, and then 8 bits of zeros for the first one, and then that's the first one, and then another 8, 1, 2, 3, 4, 1, 2, 3, 4, and then the last one, 1, 2, 3, 4, 1, 2, 3, 4. So 3 heads, and that means 8 here, 0 here, 0 here, 0 here, which would give you /8. And if you convert it to decimal, that would have been 255 and that's 0.0.0. But in this case, that's if we have the default or the class for class A. But in this case, what we're looking at is /26. So if you have 8, what's the is instead of only 8 here, what do we have? We've got another 8 here, another 8 here. That gives you 24, and then 2 bits from there. So a total of 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, and then 2 here. That's 8, 8, 8. That's 24, 25, 26, and then the remaining zeros. So that gives you 8 here, 8 here, 8 here, and 2 here, which is 26. And if we convert it to decimal, it's going to be 255, 255, 255, and it's going to be 128 plus 64, and that's going to be 192. So this is a mask. You would see that IP written either 10.0.0.0/26, or we would have 10.0.0.0, and then the subnet mask 255, 255, 255, and then 192. You can have it either /26 or in this format. And in this case, what do we see? We would expect the first octet only to be 8 ones, but now we have this one all 8, this all 8, and 2 here. Our N, that means the original, it should be zeros here, but it's not. So this 8, this 8, this 8, this 2, I mean, together, that's 8, 8, 16, 18. That's becoming, what's it, 8 and 8, that's 16, and then 2, that's 18. 18. That means, how many subnets do we have? We have 2 to the power of n, which is going to be 2 to the power of 18. Let's calculate that. So 2 to the power of n, which is 18, it's going to be 262,144. So 262,144 means 262,144 networks. That's large. So let's imagine this is like 1,000 subnets, 2,000 subnets, 2,000 different networks, and this is large number of networks because the n is a lot here and the h is less. So in each network out of this 262,144 networks, in each one you would have how many valid hosts? So h equal to, you only have 6 here, 6, and that becomes 2 to the power of h minus 2. So 2 to the power of 6, that's going to be 64 minus 2, 62 valid hosts. So in each one you have, out of this 262,000, you have in each one 62 valid hosts. So it means you have multiple locations, a lot of them, this number, but in each one you have a small number like 62, here 62, like that. So and it's the opposite of the previous example. More networks, less hosts. The previous one was less networks, but more IP addresses in each. So what do? We need to calculate the block size then. The block size is going to be 256 minus the mask. So what's that mask? This is the subnetted one, which is a mixture of zeros and ones. So 256, and if you have 1 1 is 192. So we subtract the 192. The block size is 62. That means we need to calculate, this should be 64. The block size is 64. Apologies, I put there 62. So we have the block size, but the one that's changing is here, this octet. So it will be 10.0.0. This will continue until it reaches 63. Because the second one will start from there, and then it will continue, and it will be 10.0.0. After 62, we will go to 127. So the second one will start from, let's not say continue, but start from 64, and this will continue all the way to 127. Okay, then after 127 we have 128, and that's going to be 10.0.0.128, and will continue until it reaches 191. Then from 191 it will continue and start from 192 until it reaches 255. So, and that's going to be the network start. Always write the full IP, and then that's the last. So we have now this started from 0 and ended at 63. Second one started from 64, ended at 127. Third started from 128 to 191, then 192 to 255. Now what next that can happen? Then when this completes and it becomes 255, what happens? We need to move to this octet because we borrowed bits, and that will continue until it reaches 255, and then this will continue until it reaches 255. So how do we calculate that? The second one, let's say we reach the last maybe a number of subnets, and that will be 10 until this becomes full, and that becomes full. Maybe the starting point, let's start with that. It will continue until it reaches 63. Then the second one will be 64. That means 10, 255, 255, and then it will continue until it reaches 127. Then the third one will be starting from 10, 255, 255, 128 until it reaches. So we continue the same way until that completes. You can continue from 0, and then because we have 0 here, until it reaches 1, until it reaches 1, 2, sorry, here 1, 2, 3, up to 255. When that becomes 255, this will again start from 0 to 63, 64, and then this will be continuing every time one will be moved to here, that kind of move. So until the last one you reach, which is 255, 255, and then you reach the last bit, which is 255. So that's the broadcast of the last. So if you create a long table, that I think is going to be 262. I keep saying 2000. It is 262,144. So that number of subnets, it's difficult to put in the table. That's why I just capture one of them. So try to practice some of the class A, some of the class B, some of the class C, which are all discussed in this channel. Have a look. The more practice you do, the more understanding and more knowledge you'll have in this, and then you learn how to design based on requirements. Large subnets with small number of hosts, and whatever the requirements are. That way you will be able to create networks. Before you implement them, you can design. So thank you. I hope that was useful. I'll see you in the next video.